Imagine a devastating earthquake strikes a crowded city. Hundreds of bodies are recovered from the rubble. Families are desperately searching for their loved ones. But who are these victims? How do we identify them? How does science step in when chaos takes over? Mass disaster management, forensic aspects. Before we dive into the forensic role, let us first understand what exactly is a mass disaster. A mass disaster, also called a mass casualty incident or MCI, is any event that results in a large number of deaths or injuries beyond the routine capacity of local medical and emergency services. Mass disasters are broadly classified into two types. Type 1, closed disasters. These involve a defined and known group of victims. For example, a plane crash, a train accident, or a building collapse. Here, a passenger manifest or register helps narrow down the victim list. Type 2, open disasters. These involve an unknown number of victims from the general public. For example, earthquakes, tsunamis, bombings, or floods. The victim pool is unlimited, and identification becomes far more complex. Examples of mass disasters include the 2004 Indian Ocean tsunami, the September 11th attacks in the USA, the 2013 Rana Plaza collapse in Bangladesh, and natural disasters like cyclones and floods. Now, why is forensic science so essential in mass disasters? When large numbers of people die simultaneously, the normal process of identification and investigation completely breaks down. Bodies may be badly decomposed, burned beyond recognition, fragmented or dismembered, mixed together, making it impossible to identify individuals visually. In such situations, forensic science provides the systematic, scientific tools needed to identify victims accurately, preserve evidence, and support legal and humanitarian processes. Forensic science in mass disasters serves three critical purposes. 1. Humanitarian, returning identified remains to families. 2. Legal, establishing cause and manner of death. 3. Criminal, detecting if the disaster was intentional, like a bombing or sabotage. The gold standard for identifying victims in mass disasters is the DVI, Disaster Victim Identification Protocol, established by Interpol. The DVI process is divided into 5 phases. Phase 1, the scene. The site is treated as a crime scene. The area is cordoned and secured. A grid system is established for systematic searching. Every body or body part is tagged with a unique reference number. GPS coordinates are recorded for each recovery location. Photographs and videos are taken before anything is moved. Phase 2, post-mortem data collection. Bodies are transported to a temporary mortuary, a disaster mortuary. A full forensic examination is performed on each body. This includes a full external and internal examination, collection of fingerprints, dental charting called odontogram, DNA samples, blood, hair, bone, or teeth, personal effects, jewelry, clothing, tattoos, or implants, and cause of death assessment. Phase 3, ante-mortem data collection. Simultaneously, family liaison officers gather information about the missing persons. This includes medical and dental records, previous fingerprint records, DNA from family members, photographs and personal descriptions, blood group, and previous X-rays. Phase 4, reconciliation. Post-mortem data is compared with ante-mortem data. This matching is done digitally using software like PLAS Data DVI system. A forensic expert team reviews potential matches. Phase 5, debriefing. All findings are reviewed. Identified remains are released to families. Unidentified remains are stored with proper documentation for future reference. In DVI, identifiers are classified as primary and secondary categories. Primary identifiers are considered definitive proof of identity. There are 3 primary identifiers. 1. Fingerprint identification. Fingerprints are unique to every individual. Even identical twins have different fingerprints. In disasters, fingerprints are collected from recovered bodies and compared with existing police or civil databases. Even severely burned fingers can sometimes yield usable prints, using special techniques like rehydration. 2. DNA profiling. DNA is the most powerful identification tool available. It can be extracted from blood, hair follicles, teeth, bone, especially femur and tibia, and soft tissue. The victim's DNA profile is compared with direct reference samples, like a stored medical sample, or kinship analysis, comparing DNA from parents, siblings, or children. DNA identification was used extensively in the 9/11 attacks, the 2004 tsunami, and many airline disasters.
3. Forensic odontology. Teeth are the hardest structures in the human body. They survive fire, decomposition, and trauma remarkably well. A forensic odontologist compares the dental chart of a victim, called a post-mortem odontogram, with existing dental records from the victim's dentist. Tooth fillings, root canal treatments, crowns, and missing teeth create a unique dental profile for each individual. Secondary identifiers support but do not alone confirm identity. They are used alongside primary identifiers. These include medical implants, like pacemakers, hip joints, or breast implants, which carry serial numbers traceable to the manufacturer, tattoos and scars, unique physical markings, clothing and personal belongings, skeletal x-rays, comparing old fractures or bone abnormalities, blood group. Though not unique, it can help eliminate non-matches, physical description, height, weight, eye color, age estimation. When bodies are skeletal, reduced to bones, forensic anthropology plays a vital role. A forensic anthropologist can determine from skeletal remains sex by analyzing the pelvis and skull, age by examining bone development, tooth eruption, and epiphyseal fusion, stature by measuring long bones like the femur, ancestry through skull morphology, trauma, identifying fractures, cut marks, or ballistic injuries on bone with bone. In mass grave investigations, like those following genocides or war crimes, forensic anthropology is indispensable. The work of forensic anthropologists in Srebrenica, Rwanda, and Argentina